Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. Here, I also hope all of you are well by the mercy of Almighty and carrying on your regular studies, staying at home. Dear student, in our today's class, we are going to discuss some important creative question from our last board exam, that is a board exam of 2020, and today we will discuss two creative questions from our second chapter, that is a chapter of motion. First we will discuss a creative question from Rashtriya Board 2020 from motion chapter, then we will discuss the next creative question from Kumilla Board 2020. Right, dear student, I hope this creative question will help you a lot for your upcoming exam, and you have to practice this type of question staying at home. Dear student, so let us start our class. Right, dear student, here is our first creative question. In the question, they said that the following table shows the magnitude of velocity of a moving car for different interval of time. Here is the table. In the first row of the table, they show the different type of velocities, and in the second row, they show the time interval. Right? At the starting time, that is when the time was 0, the velocity was 2 meter per second. When the time is 5, it was 4 meter per second. When the time was 10 second, the velocity was 6 meter per second. Again in this 15 second, the velocity was 6 meter per second. But when the time was 20 second, the velocity was 7, and finally when the time was 25 second, the velocity was 8 meter per second. Right? And the questions are, what is periodic motion? And in question B, they said that oscillatory motion is a periodic motion. Explain. In question C, that calculate the distance traveled by the car in 15 seconds. And finally, we have to draw and analyze the velocity versus time graph for the car. That is, using this table, we have to draw a velocity versus time graph, and we have to give the explanation. Right? So, dear student, first we have to give the definition of periodic motion. You know what periodic motion is. The definition says that if the motion of a moving body is such that it passes repeatedly through a definite point in same direction in the same manner in a definite interval of time, then this type of motion is called periodic motion. Right? I hope you got it. Now we are going to explain that the oscillatory motion is a periodic motion. Dear student, already we have defined what periodic motion is. Now we have to give the definition of oscillatory motion, and from the properties of these two motion, that is properties of oscillatory motion and periodic motion, we can explain that oscillatory motion is nothing but a periodic motion, because periodic motion is related with time. Right? In definition we see that in a definite interval of time. So oscillatory motion also related with time. It takes a regular interval of time. So now we are going to write the definition of oscillatory motion. Okay, dear student, first we have to write the definitions of oscillatory motion and periodic motion. Here the definition of periodic motion is given, as well as the definition of oscillatory motion. In periodic definition of periodic motion, we have already explained, if the motion of a moving body is such that it passes repeatedly through a definite point in the same direction in the same manner in a definite interval of time, then this motion is called periodic motion. Again, the repeated motion in which an object repeats the same movement over and over in a regular interval of time is called oscillatory motion. So from these two definitions, we can see that the characteristics of oscillatory motion cover the characteristics of periodic motion. So all oscillatory motion will be periodic motion. Right? Dear student, now we are going to solve our question C. That is, we have to calculate the distance traveled by the car in 15 seconds. Right? Dear student, from the graph we can see that in first 15 seconds the characteristics of motion changes, because in first 10 seconds, from 0 to 10 seconds, the velocity of the moving car increases uniformly. That is, there is a uniform acceleration. In 0 second the velocity was 2, in 5 seconds the velocity was 4, and in 10 seconds the velocity was 6. That is, in regular interval of time the change of velocity was regular. So we can say that up to 0 to 10 seconds there is a acceleration, right? And from 10 seconds to 15 seconds the body moves with uniform velocity. That is, at 10 seconds the velocity was 6, and 15 seconds the velocity was also 6. So there are two types of motion in first 15 seconds. So we have to calculate the distance traveled by the car in 15 seconds in two steps, right? Because there are two types of motion. First 10 seconds the motion was with uniform acceleration, and second 5 seconds the motion was with uniform velocity. So to calculate the distance, we have to calculate the distance for first 10 seconds. So we can write that for first 10 seconds, right? Initial velocity u was 2 meter per second, final velocity v was 6 meter per second, time t1 is equal to 10 seconds. Already we have mentioned that for first 10 seconds. So distance s1 is equal to, so in that case, since we have already got initial velocity, final velocity and time, we can calculate the distance like this: u plus v divided by 2 into t1. Okay, so here u is 2, v is 6 divided by 2 and multiplied by 10. So after the calculation you will get 8 divided by 2, 4 multiplied by 10. So it will be 40 meter, right? Dear student, now we have to calculate the distance for the next 5 seconds. So we can write for next 15 minus 10 or 5 second. Here uniform velocity v is equal to 6 meter per second and time t2 is equal to 5 second. So here distance s2 is equal to v into t2. Here v is equal to 6 meter per second and time is equal to 5 second. So after the calculation you will get 30 meter. So total distance in 15 seconds, total distance s is equal to s1 plus s2, right? So here s1 is 40 meter and s2 is 30 meter. So after the calculation you will get 70 meter. So we can write that the car travel 70 meter in first 15 seconds, right? I hope you got it. Now we are going to draw and analyze the velocity versus time graph for the car. Dear student, first we have to draw two axes for the time axis and velocity axis, right? In the horizontal axis we have to plot the different values of time, that is 0, 5, 10, 15, 20, 25, and in the vertical axis we have to draw the different velocity magnitude of the velocity. Okay, now we have to plot the different velocities against the values of time. In the graph they show that when the time was 0 the velocity was 2, that is when the time was 0 the velocity was 2. This is the point for the first 0 second. And when the time was 5 the velocity was 4, that is when the time was 5 the velocity was 4. So at time 5 second the velocity was 4, right? At time 10 second the velocity was 6, at time 10 second the velocity was 6. Okay. Dear student, then when time was 15 seconds, the velocity also was 6. So when the time is 15 seconds, the velocity also 6 meter per second. When the time is 20 seconds, the velocity was 7. When the time is 20 seconds, the velocity was 7. Here the velocity is 6, 7, 8. So we have to place the point in the alignment of 7. Here I think this indicates in the level of 7, but when the time is 25 seconds, the velocity is 8 meter per second. So I think in the level of 8 it is like this. Okay. So dear student, now we have to add the point. For the first 10 seconds, the velocity of the car increases uniformly. Then next 5 seconds, the velocity was constant, and next 10 seconds, the velocity again increases uniformly. Right? Dear student, this will be the graph of the motion, that is graph of velocity versus time for the car. Now we have to give an analysis or explanation. From the first 10 seconds, the car moves with uniform acceleration because with time the velocity changes uniformly. So if we would like to calculate the acceleration for the first 10 seconds, here acceleration a1 is equal to v minus u divided by t. So for first 10 seconds, velocity, final velocity was 6 and initial velocity was 2. So 6 minus 2 divided by time. Here required time was 10 minus 0, that is 10 minus 0. So we can write 4 divided by 10, that is 0.4 meter per second square. Right? So acceleration in first 10 seconds was 0.4 meter per second square. And next 5 seconds, that is 10 to 15 seconds, the body moves with uniform velocity. From the graph we can say that. And in last 10 seconds, that is 15 to 25 seconds, the velocity of the car again increases. So in that case, the acceleration for the next 10 seconds, if we calculate v minus u divided by t, here final velocity is 8, initial velocity was 6. So 8 minus 6 divided by, here time is 25 minus 15. So 25 minus 15, or 2 divided by 10, that is 0.2 meter per second square. Right? That student, in this way we can explain the nature of the graph of velocity versus time graph for the moving car. Right? I hope you got it. Dear student, here is our second creative question, and the question is from Kumilla Board 2020, and our previous question was Rajshahi Board 2020. This question is almost similar to our previous or first question. In the same way, they said that the following table shows the magnitude of velocity of a moving car in different interval of time. Here the value only the different in time here the time interval are 0, 2, 4, 6, 8, 10, 12 and 14, and the velocities in the respective times are 0, 5, 12, 12, 12, 8, 4 and 2. That is, initially the velocity increases and after some time the velocity was at a constant value, and finally it decreases from 12 to 2 meter per second. Right? Dear student, here the questions are: what is momentum? Why is it difficult to walk on sand? Determine the distance traveled by the car in first 8 seconds, and finally draw a velocity versus time graph from the above table and analyze the change of velocities. I think this question is almost similar to our previous question. So here the first question is, what is momentum? Dear student, you know what momentum is. The product of mass and velocity of a moving body is called its momentum, right? So we can write momentum is the product of mass and velocity of a moving body is called its momentum, right? Momentum is denoted by P. So P is equal to mv. If m is the mass and here v is the velocity, so product of mass and velocity is called momentum. So momentum is a vector quantity. Since v is a velocity is a vector quantity, so momentum is also a vector quantity. Now we have to explain why it is difficult to walk on the sand. That's when, you know, when we apply force, suppose this is ground or earth, if we apply force, suppose this is our foot, when we applied force on the earth or ground in the inclined way, according to Newton's third law, the ground or earth will also apply a opposite and equal force on our foot, and due to the reaction force we become able to move in forward direction. But when we move over the sandy road, like the slippery road or muddy road, we don't feel like the reaction force like the normal mud. So in case of sand or slippery road or muddy road, we feel less reaction force, so it is difficult to walk on a sandy road or slippery road or muddy road. Dear student, I hope you got it. Now we are going to solve our question C, that is we have to determine the travel distance in first 8 seconds. Okay, from the graph we can see that in first 2 seconds, that is when time increases from 0 to 2 seconds, the velocity increases from 0 to 5, right? And in next 2 seconds, that is time interval from 2 to 4 seconds, the velocity increases from 5 to 12. So the increase of velocity in first 2 seconds and next 2 seconds was not same. In first 2 seconds the velocity was increases by 5 minus 0 or 5 meter per second, and in next 2 seconds the velocity increases from 5 to 12, that is here the velocity increases by 12 minus 5 or 7 meter per second. So in first 2 seconds the acceleration was 2.5 meter per second, and in next 2 seconds the change of velocity or acceleration was different, and from time to 4 to 8 seconds the velocity was constant. So in first 8 seconds the characteristics of motion of the car changes in 3 times. In first 2 seconds the velocity increases from 0 to 5 seconds, in next 2 seconds the velocity increases from 5 to 12 seconds. Here are 2 changes, and finally from 4 to 8 seconds the body moves with uniform velocity. So we have to calculate the distance for first 8 seconds in 3 steps. In first 2 seconds, for first 2 seconds, here the initial velocity u was 0, final velocity v is 5 meter per second and t1 is 2 minus 0 or 2 second, right? So here distance is s1 is equal to u plus v divided by 2 into t1. Here u is 0, v is 5 and divided by 2 multiplied by t1. Here t1 means 2. So here distance is 5 meter. For the next 2 seconds, that is from 2 to 4 second, for next 4 minus 2 or 2 second, right? Here u is equal to 5 meter per second, v is equal to 12 meter per second, t2 is equal to 4 minus 2 or 2 second, right? So here distance s2 is equal to u plus v divided by 2 into t2. Here u is 5 plus v is 12 divided by 2 multiplied by 2. So after the calculation we will get the distance will be 17 meter. And for the next 4 to 8 second, for last 8 minus 4 or 4 second, right? And in this time period the body moves with uniform velocity. Here the uniform velocity v is equal to 12 meter per second and time t3 is equal to 4 second. So distance s3 is equal to v into t3. Here v is equal to 12 meter per second and time is 4. So it will be 48 meter. So total distance is s is equal to s1 plus s2 plus s3, right? So value of s1 it was 5 plus value of s2 it was 17 and finally value of s3 was 48, right? So it will be 48 plus 22, that is 70 meter. Dear student, this is the distance traveled by the body in first 8 seconds, right? Okay, dear student, to draw the velocity versus time graph, first we have to draw these two axes. One is horizontal axis which represents the time and another is vertical axis which represents the velocity in different time interval, right? First we have to plot the values of time and values of velocities. From the graph we see that when the time was 0 the velocity was 0, so it indicates the origin. Next, when the time was 2 the velocity was 5, that is when the time was 2 the velocity was 5. 5 means 4 5. This point indicates the velocity at 2 seconds, right? And when the time was 4 the velocity was 12. When the time was 4 the velocity was 12. So this is the second point of our graph, and up to 8 seconds the velocity remain 12. So up to 8 seconds the velocity maintains 12. At 6 and 8 the velocity remain same. And at time 10 seconds it reduces to 8 meter per second. When the time was 10 it reduces to 8 meter per second, right? I think this indicates the velocity at time 10 seconds, and when the time is 12 it reduces to 4 meter per second. When the time is 12 it reduces to 4 meter per second, right? I think this point indicates the velocity at 12 meter per second, and when the time was 14 the velocity reduced to 2 meter per second. When the time was 14 the velocity reduces to 2 meter per second. Okay, that is student, now we have to add the point successively. First we have to draw these 2 points, and it shows the change of velocity from 0 to 2 seconds. Then we have to add these 2 points which will represents the change of velocity in the time interval of 2 to 4 seconds. Then we have to add these 3 points which shows the constant velocity of the body in time interval from 4 to 8 seconds. Then we have to show the decrease in velocity in time interval of 8 to 10 seconds, then 10 to 12. So we have to add these 2 points. Then it reduces to 4 to 8 in the time interval of 12 to 14 seconds. Dear student, this is the velocity versus time graph according to this table, right? So observing this graph, we can explain that in first 2 seconds the velocity increases rapidly, that is it increases from 0 to 4 seconds, then it increases from 5 to 12 seconds, then it moves with uniform velocity, maintaining the velocity 12 meter per second, then the velocity reduces from 12 to 8 seconds, then 8 to 4 seconds, and then 4 to 2 seconds. Dear student, I hope you got it. You have to practice this type of creative question for your upcoming exam. Okay, we have today we have discussed 2 creative questions from our board exam. Our first creative question was from Rajshahi board, and second creative question, that is this question, is from Kumilla board 2020, right, dear student? So good wishes for you. May Allah bless all of you. Assalamu alaikum.